Hello future engineers, there is another video in dynamics, particularly on kinematics of particles. The preliminary ideas and concepts are explained in the first part of this playlist, and I hope that you will be able to understand the explanations and the solutions to these problems. And I also hope that when confronted with problems in dynamics, you will be able to solve them by your own. So here is the first problem, problem 9. There are two problems in this video. The brakes of a car are applied, causing it to slow down at a rate of 10 feet per second square. Knowing that the car stops in 300 feet, letter A, how fast the car was traveling immediately before the brakes were applied. So that's the initial velocity. That's the first question. The final velocity is 0, and the distance traveled would be 300 feet during this acceleration, which is negative 10 feet per second square. So the acceleration is constant in this case, and the formulas derived in the first part, earlier part of this playlist. The time required for the car to stop. So here is the given situation, the figure. So for constant acceleration, there were three formulas also that were derived, and the direct formula for this case would be velocity sub x. So we put the subscript because the movement is along a straight path and along x. So v sub x quantity square, or v final x component of the final velocity square, equals x component of the initial velocity square plus 2 times a sub x quantity x minus xo. Because the car starts at this position where the initial position is 0, then x sub o would be 0. So v sub x square equals v sub ox square plus 2ax times quantity x minus xo, where again xo is 0, final velocity is 0, and x is 300 feet, ax is negative 10 feet per second square. So 0 square equals vox square plus 2 quantity negative 10 times quantity 300 minus 0. So vox square equals 20 times 300, so that's 600. Therefore, vox is square root of 6,000 rather, 20 times 300. So vox is square root of 6,000, and of course it is in that direction, so vox is positive 77.46 feet per second. So that's the initial velocity before the car comes to a stop at this position after traveling 300 feet. Then letter B, the time required for the car to stop. So we use another formula with constant acceleration, Vx, or velocity final, equals Vox plus acceleration sub x times t. So we have that formula derived for constant acceleration. Vx equals Vox plus ax times time. So Vx again is 0, Vox is 77.46 feet per second, ax is negative 10, then we can solve for time. Another way is we have x minus xo, where xo is 0, equals vox t plus 1/2 ax t square, and that will give us an equation which is quadratic, but this is the simpler one, so we'll use this. So 0 equals 77.46 plus negative 10 times time. So time is 77.46 over 10, and that's 7.746 seconds. So that's it for this first problem. We proceed to the second one. The acceleration of a particle is defined by the relation a equals 3e to the negative 0.2t, where a and t are expressed in meters per second square and seconds respectively. Knowing that x equals 0 and v equals 0 at t equals 0 initial condition, determine the velocity and position of the particle when time is 0.5 seconds. So here we have to derive expressions for velocity and position. So first, for velocity, because acceleration is derivative of velocity with respect to time, and it is equal to 3e to the negative 0.2t. So acceleration dv dt is 3e to the negative 0.2t. So dv therefore is 3e to the negative 0.2t times dt. So integrating, but before we integrate, remember that from calculus, integral of e to the u du is just e to the u. But u here is negative 0.2t, so the differential is negative 0.2 differential of t. So we divide by negative 0.2 and multiply by negative 0.2 to set up the integral for us to easily evaluate the integral. So dv is 3 over negative 0.2, then times e to the negative 0.2t times negative 0.2 dt, so that this is in the form e to the u differential of u. So 3 over negative 0.2 is negative 15. So integral of dv from c to v is negative 15. Integral of e to the negative 0.2t times negative 0.2 dt from 0 to t. So we have limits here. There's no constant of integration. Again, integral of e to the u, this is differential of u, is just e to the u. So therefore, integral of dv is just v. So v minus 0 is v, equals negative 15 e to the negative 0.2 times t minus e to the 0, lower limit. So v is negative 15 e to the negative 0.2 t minus e to the 0. Then since e to the 0 is 1, v is negative 15 quantity e to the negative 0.2 t minus 1. So next, we replace v, which is dx dt, to derive expression for the position. So dx dt equals negative 15 e to the negative 0.2 t minus 1. So that means dx is negative 15 e to the negative 0.2 t plus 15 dt. So distribute negative 15 e to the negative 0.2 t dt, then negative 15 times negative 1 is positive 15 dt. Integrating limits 0 to x for x and dt 0 to t. And before we evaluate the integral of this first term in the right side, we divide by negative 0.2 and multiply by negative 0.2 also to set up the integral so that it will be in the form e to the u du. So dx is negative 15 over negative 0.2 e to the negative 0.2 t times negative 0.2 dt plus 15 dt. 15 over negative 0.2, negative 15 over negative 0.2 is 75. So integral from 0 to x of dx equals 75. Integral 0 to t of e to the negative 0.2 t times negative 0.2 dt plus 15t from 0 to t. So the integral of 15 dt is just t. So t minus 0, so it's 15t. Then this one is e to the u. So e to the negative 0.2 t minus e to the 0, which is 1 again. So integral of dx is just x minus 0 or x. So x equals 75 e to the negative 0.2 t minus 1 plus 15t. Then we can now compute the velocity and the position by substituting t equals 0.5 seconds. So first, for velocity, negative 15 quantity e to the negative 0.2 times 0.5 minus 1. So the velocity when time is 0.5 seconds is equal to 1.427 meters per second. Then the position, we have derived the position here. We substitute t equals 0.5. So x is 75e to the negative 0.2 times 0.5 minus 1, then plus 15 times 0.5. So using your calculator there, x is equal to 0.3628. So x sub 0.5, x position when time is 0.5 second, 0.3628 meters. So that's it for this video. I hope that you were able to follow the explanation, understand the explanation and the solutions to this problem.